talking about algebraic expressions. So we've been learning about numeric expressions, and numeric expressions we know are just sentences, math sentences that have both numbers and operations. Well, now as we're jumping into chapter 5, we're going to be learning about algebra and integrating in letters. So algebraic expressions are math sentences that have numbers, variables, and operations. So we're going to have math sentences that have numbers, operations, and variables. So an algebraic expression is a math sentence that has numbers, operations, and variables. All right, so let's go ahead and pull out the important information here. Algebraic expression has numbers, operations, and variables. And variables are just a fancy word for letters. This looks a little bit blurry. Let's make this not look so blurry. There we go. All right. So we are going to first talk about what an example of one would look like. So I'm going to write an algebraic expression for you, and I'm going to color code it because there's lots of different parts to an algebraic expression, and it's really important that we know the vocabulary of each piece of an algebraic expression. So we're going to write down each part of an algebraic expression. So the first thing that we're going to look at is all the different parts. So I'm going to use red, I'm going to use blue, I'm going to use, I don't know if the purple is going to show up next to the blue, so let's use pink. Yeah, that works. And I'm going to use green. All right, this is an example of an algebraic expression. Okay, so this is an example of an algebraic expression right here. So it has everything in there. It has numbers, it has letters, and it has an operation in there. Sometimes it could be multiplication, sometimes division, sometimes, subtraction. So let's talk about this first number right here. This number stuck to a letter. This right here is a coefficient. I want you to think of like a co-pilot or a co-captain or like a co-worker. Those are things that go together, right? A co-pilot helps the regular pilot, right? Or a co-worker works with somebody else. A co-captain works with the regular captain. So thinking of the word co, a coefficient works with this letter. It depends on it. It cannot stand alone, okay? So this number here works with this p or any variable and is called a coefficient. Okay, it's codependent. Coefficient. So a coefficient is a number that works with a variable. I'm sorry. I have these little guys outside my window that play music, and it's supposed to turn off when the sun rises, but every time somebody drives by and has their lights blaring, it like sends the sensor off, and so I'm sorry if you can hear that in the background. Okay, a number that works with a variable to change value. All right, the variable. Gosh, we're just all kinds of messed up today, aren't we? Oh, goodness. Okay. The P is the variable. Okay? The variable is a letter. It's a placeholder. It doesn't have a value yet. Okay, so this is a placeholder. A variable is a letter. That holds the place of a number. Okay? It changes. It can change over and over and over and over again. Okay? It can be any number, it can be any value, and it will change. Okay, this is our operation. Our operation actually has a really important job. Our operation, it separates the terms. So each of these is a term. It works like a comma. So like in regular sentences, like in language arts, you would use a comma to separate important parts of a sentence. This kind of works like a comma. I know, language arts and math, weird. Okay, and last but not least, we have this 4. This 4 is not just called a number anymore. I know. What are we doing to you? This 4 is called a constant. This 4 is called a constant because it constantly is a 4. The number that is always by itself is called a constant. It stands alone. It doesn't need anything to have a value. It is able to always know its worth. It doesn't need to change. A 4 is a 4 is a 4. No matter what. If this was a 5, it would constantly be a 5. If it was a 10, it would constantly be a 10. It never changes its value. When we look at it, we see a 4, we know it's a 4. So constants are numbers or terms that stand alone and their values don't change. Okay? So this is a term without a value. Or I'm sorry, a term without a variable. Term without a variable. The value never changes. Some of us have some friends that are pretty constant people in our lives, right? They never change. We can depend on them always for everything. Okay, so this is your math vocabulary. There's a lot in this chapter, so I want you to make sure that you have an idea of your math vocab. So now we're going to sort out and put these things into different categories, these terms into different categories. So how do we identify parts of an algebraic expression? That is our question. How do we identify parts? identify parts of an algebraic expression. How do we identify parts of an algebraic expression? Well, we are going to do a couple different things to be able to do that. So the first thing that we're going to do is we are going to make some lists. So we're going to separate our paper down below into like a boxed off area like this. Except your boxed off area is going to look much better than mine is. Okay, and now the first example that we're going to look at is not with that color because we've already used that color and I don't want to make anybody confused. So let's go back to purple. All right, so our example is 5x plus 13. All right, so the first word that we want to look at is the word terms. All right, so it says to list the terms. Well, we have to decide, well, what are terms? Terms are each part of the expression. Okay, so terms are each part of the expression. They're each part of the expression. So we're going to look at this and we are going to see that there are two different terms here. We have 5x and we have 13. Two separated by there. So we're going to each part of the expression and we're just going to add this, separated by an operation. We saw up above in our notes when we put this operation, it works like a comma. We're just going to think of this like a comma. So we're just going to rewrite this right here in this list. 5x and 13. Those are the terms. 5x and 13 are the terms. Now we want to know what is the coefficient. So what is the coefficient? Well, we wrote coefficient in red, so I'm just going to rewrite that in red. My coefficient, oops, let's come up here. My coefficient was 5x. So I only have to list 5x. So the coefficient is 5x. The variables. Well, variables was blue, so we're going to write variables. The variables up here we have listed are x. So x is my variable. And the last part of this list is the constant. Which value is never going to change in this list? Well, the value that's never going to change is 13. 13 will always stay 13. So that is my constant. Okay, this one I want you to go ahead and try to do without me. Oh, I said I was going to use purple. Sorry. Okay, so example B says, oh, actually, I'm going to do this one with you. Oh my gosh, these guys outside are driving me crazy. 2z squared plus y plus 3. And then I'm just going to draw another line right here because we'll do our try it right here. If you don't have room for a try it right there, you can put your try it down below. Okay. All right. So the first thing we want to do is our terms. Okay. So let's list the terms. Where do you see the terms? Okay. The terms. So let's box those up. The terms are 2z squared, anything that's separated by an operation, right? Y is a term, and 3 is a term. So 2z squared, just replace the operation with a comma. Y and 3. Coefficients. Remember, the coefficient is dependent on a letter to do its job. It doesn't have value unless it has a letter next to it. So which one of these has a letter stuck to it and won't have any value unless that letter is there? Yeah, the 2z squared. So this is a coefficient, 2z squared. And I don't see any others. Okay, let's talk about variables. Variables in this list, in this algebraic expression, I see z and I see y. So this one actually has 2, z and y. And last but not least, our constant, our value that stands alone, is 3. Okay, it is your job now to try this one on your own. This one says 15 plus 3w plus 1/2. So find the terms, the coefficients, the value, the variables, and the constants. Go ahead and pause the video so that you can do the try it on your own. Ignore my line that goes right there. I'm sorry, that's so messy. It's gross looking. I apologize. All right, I'm going to go ahead and solve this now. All right, the terms. 15, 3w, and 1/2. So the terms are 15, 3w, and 1/2. Coefficients. I have one coefficient, and that is 3w. I have a variable. It is w. And my constant, I actually have 2 constants. I have 15 and I have 1/2. All right, how did you do on that? Go ahead and mark yourself right now. How did you do? Give yourself a 3, 2, or 1. All right, and then head on over to the next part of your assignment. I'm going to turn the